My dear students, this is our sixth lecture. Please pay attention. We will discuss time series decomposition. In many instances, the pattern that we made or founded can be broken down or decomposed into sub-patterns that identify each component of the time series separately. So, the time series can be decomposed. Such a breakdown can frequently aid in better understanding the behavior of the series, which facilitates improved accuracy in forecasting. So, decomposition assumes that the data are made up as follows. Data equal to the pattern plus error. And we know that the pattern consists or composed from trend, cycle, seasonality, error. Decomposition methods usually try to identify two separate components of the basic underlying pattern that tend to characterize economic and business series. These are the trend cycle and the seasonal factors. The seasonal factor relates to periodic fluctuations to constant lengths that are caused by such things as temperature, rainfall, month of the year, timing of holidays, and corporate policies. So, we know what's meant by seasonal factors. The trend cycle represents longer-term changes in the level of the series. The trend cycle is sometimes separated into trend and cyclical component. Here in our resource or our book, the trend cycle separated into these two components, trend and cyclical. But the distinction is somewhat artificial, and most composition procedure leaves the trend and cycle as a single component known as the trend cycle. The general mathematical representation of the decomposition approach is yt is function of tt, st, and et, where yt is the time series value, which is actual value, at period t, or at a single time or given time. st is the seasonal component at period t, and also tt is the trend cycle component, as we discussed in the last slide. tt is the trend cycle component at period t. Finally, et is the irregular or remainder component at period t. So, we should to know that there are two forms of decomposition model. The first one is additive decomposition model, and the second one is the multiplicative decomposition model. The additive model. It is a common approach which is to assume equation has the additive form. We add these components to each other. Yt which is the time series value at period t, is the sum of the t component, s component, and et component. This model when the seasonal variation is constant from year to year and independent from the trend. The second one is the multiplicative model. Multiplicative model, a common approach is to assume equation has the multiplicative form. We multiply all the components with each other. So yt, which is the actual value of the time series at period t, equal to the t at time t, the s in the time t or period t multiplied by et. This model is used when the variations are variable from year to year. The components in the multiplicative model is represented as percentages rather than numbers. So we will turn to the most important point here, which is the moving average method. Moving averages are a fundamental building block in all decomposition methods. It is an important tool for time series analysis and forecasting. The trend cycle component can be estimated by smoothing the series to reduce the random variation. So we try to smooth the series Y to reduce the random variation. A range of smoothers is available, but we will begin with the simplest and the oldest smoother, which is a moving average. Moving averages provide a simple method for smoothing the past history data. The idea of moving averages is that observations which are nearby in time are also likely to be close in value. So, taking an average of the points near an observation will provide a reasonable estimate of the trend cycle at that observation. The average eliminates some of the randomness in the data, leaving a smooth trend cycle component. There are 4 types of moving averages. The first one is the simple moving average. The second one is centered moving averages. The third is double moving averages. And finally, the first type is weighted moving average. Simple moving averages we will discuss and explain it again. Simple moving average, it is the simplest form of moving averages in the simple moving average. The simple moving average is the sum of the certain values of the series divided by the number of these values, which is moving average K or MAK equal to the summation of YT plus J over K, where MAK is the moving average depending on K observations. K is the length of the moving average or degree or